We are now in Chapter 4, Section 3. You have already watched 4 videos about this section. I wanted to do one last video and tie some information together and just really make sure that you are letting each of these concepts soak in and that you're not moving on until they really make sense. Again, this can be a difficult chapter. You've got to take time with it. You've got to wrestle with it to let the concepts make sense, find places in your brain where they can connect and be usable whenever you go to do your homework or to do the test. I am on page 221. I'm going to point out some highlights, like right here where it says independent events and then gives us a rule. Make sure on your formula card you're noting where we have independent events and it's an and. So when you see it's an and, you've got to ask yourself, is it independent or dependent? If you see it's an or, you need to ask, is it mutually exclusive or not? Right here, we're at an and independent versus dependent. The formula is given, and then a couple of examples are given. Looking at these, no, I didn't want to look at these 2 examples. I want to do one on the next page. I'm looking at page 222. And on 222, it gives an example of selecting a colored ball. And so in this example, it says, let's say that there are 2 red ones and that there are 5 blue ones. And then it says 3 white ones. Well, I don't have white ones, I have yellow ones. So we're going to use yellow ones. And assume that these are in a bag that we cannot see. And let's see if I can make this taller where you can see all of them. And maybe not. These are in a bag. You see all of them here. And we cannot see, when we reach into the bag, what color we're going to draw. And so it's saying, what is the probability that you'll select 2 blue balls and then 1 white ball? But the big word in here is right here. And I'm going to grab another highlighter that says, then it is replaced. That is the alarm to go off in your brain that says, these are independent. When I replace the ball, like if I take out this yellow one, I'm going to impact the amount of balls that are there. But if I replace it, it goes back to normal. And so I really wish y'all could see all of this. I'm trying to get this document camera higher, and it's not going to go any higher. That's it. Let me pause and raise this up. Raising it up did not help any, so I found a bowl. And so in my bowl, I have put what they are suggesting for this problem. Again, I'm on page 222, example 4-25. And inside the question, it says 2 red balls. So I'll go ahead and throw those back in. We've got 2 red balls. And then it says 5 blue ones. And so here are 5 blue ones. And then it says 3 white ones. And I don't have white, I have yellow. So we have all of these in there. 2, 4, 6, 8, 10 balls. And then it says on part C, we're going to select a blue, then a blue, and then a white. What are the odds of this happening, or what's the probability? But here's the key word. When it says it's replaced, in other words, if I do select blue and leave it out, I just change the amount of balls that are in this bowl. That impacts the next draw. It changes the probability of the next draw. Therefore, the next draw depends on what I got on the first one. So if I put it back in there, this resets it. It is back to where we started, and therefore it is independent every time I draw. And so I'm going to write down that if they're asking me to draw right here, a blue, and then a white. So the probability of getting a blue and a white, which in my case is a yellow, then that is going to be independent. It is independent. I'm going to take the probability of the first one times the probability of the next one times the probability. In other words, what's the probability of getting a blue? And I'm multiplying it times the probability of getting another blue, and then the probability of getting a yellow. So when I look in this bowl, the probability of getting blue is 1, 2, 3, 4, 5 out of 10. So this first probability is 5 out of 10. And if I happen to draw a blue ball, it says in the directions I need to put it back. So now I'm going for the second draw. When I reach in here, I've got the same thing I had at the beginning because I replaced. This time, if I happen to draw a blue one on the second one, but it tells me to replace it, now it's time to go grab a yellow one. I've got 1, 2, 3 out of the 10. So this is 3 out of the 10. And that's got me set up. All I've got to do now is start multiplying or reducing. I prefer to be lazy and reduce. In other words, 5 goes into 5 once, 5 goes into 10 twice, 5 goes into 5 once, 5 goes into 10 twice. No more of my numerator will go into my denominators. And so 1 times 1 times 3 is 3. 2 times 2 is 4 times 10 is 40. And if you'll notice what the book did, the book came over here and went ahead and multiplied straight across and got 75 over 1,000. I don't want to do it that way. I like going straight for this where I got 3/40ths, and if they want me to convert to a decimal, I can. So that is us talking about multiplication rule, independent, and here's the formula. Moving on, I am looking at page 223. And on 223, I want to point out dependent, and I want to point out that there is a formula for dependent at the bottom of the page. I also want to show that on our formula card, there is another formula for multiplication when we're going to use and, but it's dependent. So I want to go back and use the same setup we had in our other problem, and I've written in an example. This one's not in your book, but we're going to use 425C. But on 425, when it said, yes, replace the balls that you draw, this time our directions are going to be, let's go ahead and find a blue, and a yellow, but this time we're not going to replace. So our directions would look something like this. What's the probability of drawing a blue and a yellow? Wow, that looks like just exactly like what we did a while ago. But this time we're not going to replace. So I got to do the probability of the blue and the probability of, it's the probability of the first one, that's the same, but then I've got to put in the probability of getting the next blue, given that I got a blue on the first one. Well, then my next one's going to be, what's the probability of getting a yellow, given that I just got a blue on the next one of those. So it's going to be, what is going to be the probability that I'm going to get a blue again, given that I got a blue the first time, times the probability that I'm going to get a yellow, given that I got a blue that time. In other words, I really like using this illustration, because let's go for the first one. I'm about to draw and try to get a blue ball, and when I stick my hand in here, I've got 5 out of 10 that are blue in this bowl. But I get the blue ball, you know, over here, given that we got a blue ball. Since I got it, now let's look what's going on in there. What's going to be the probability of getting a blue ball this time? 1, 2, 3, 4. So it's no longer 5. It's dropped down to 4. And 1, 2, 3, 4, 5, 6, 7, 8, 9. It's no longer 10 balls. It's 9. Here's the big difference between dependent and independent. This is no longer an independent example. Every time I draw a ball, I'm not replacing it, and that is changing the outcome of the next draw. So let's say it happened. I drew a blue ball, and I am not replacing it. And so now I need to find out what's the probability of getting a yellow ball, given that I did just get a blue ball and a blue ball. Well, in that case, I still have 3 yellows, so I still have a 3 in my numerator, but now I have 1, 2, 3, 4, 5, 6, 7, 8 in the bowl. So notice how my denominator has gone down by 1 because I kept not replacing. My blues went down by 1, but I never touched the yellows. So again, I can do some reducing, and this is where sometimes people will say, you can't reduce like that. Well, we learned some errors when we're trying to survive mathematics. As long as I am multiplying and multiplying, I can kill what I want to kill. Like 5 goes into 5 once, 5 goes into 10 twice. Well, this 4 and this 8 have stuff in common, so I can kill that way. 4 goes into 4 once, 4 goes into 8 twice. I can also catch the 3 and the 9. 3 goes into 3 once, 3 goes into 9 3 times. And now in my numerator, I've got 1 times 1 times 1, and 2 times 3 is 6, times 2 is 12. Here would be the probability of grabbing the ball and not replacing, and it being a dependent event. With that being said, the final things I'd like to say about this section are, when you are doing these examples, I continue to stress to you, do not keep going until something fully makes sense to you, and you could take a sticky note and cover all of this up, and you could go repeat the whole example just using the directions and not using any notes or any helps from the book. Then you know it. I want to tell you that at the top of 225, it talks about tree diagrams, and that they can be used to aid in finding solutions to these probabilities. And you've got to figure out what works for you. Tree diagrams can be great if they work for you, or you work through making them work for you. And I want to show you one here, because this is a pretty complicated problem, and they keep getting more complicated the further we go in this chapter. It says you got a box which has 2 red balls and a blue ball. Another box has 3 balls and a red one. And if a coin is tossed, oh my gosh. So we're going to toss a coin, and if it falls heads up, we go to box 1. If it's heads down, we go to the other box. If tails is up, oh glory, then we go to the other box. Find the probability. This sounds like one of those horror stories about mathematics. To find the probability of selecting a red ball. And so here, this is a great drawing that I'm not going to spend a whole lot of time on. I'm asking it to refocus. I'm not going to spend a whole lot of time on, but you can see I've got a lot of stuff going on, and you may even want to take a screenshot of my page. If we were in class, we would talk through, just like I'm about to talk through here. The probability of going to box 1 is 1 out of 2, because remember, we're flipping a coin. If it lands on heads, it's 1 out of 2. The probability of going the route of box 2 is 1 out of 2 for it to land on tails, and then that's where it splits. In both boxes, we have red balls and blue balls. And so the probability of getting a, a red, given that we got box 1, the red balls in this first one, as you'll see up at the top, there are 2 out of the 3 that are red. But if I'm in box 1, probability of getting a blue, it's 1 out of 3. So this top line ends up with a red ball. This next line ends up with a blue ball. But wait, what if we had ended up flipping, I think it's tails? Then the same thing happens, but different contents are in box 2. It contains 3 blue and 1 red. So the probability of getting a red, given that we're in box 2, is 1 out of 4. That's a red. The probability of getting a blue in box 2 is 3 out of 4. That ends us with a blue. The ultimate question said, what's going to be the odds of getting red? With that in mind, we've gone back to getting the red and the red. Where are we? The probability down here of getting, I've got A, and that's getting red. In the end, we have a 2/6 probability and a 1/8 probability of getting the 2. I've skipped the part in the middle. Let me go back to that. The probability of getting like box 1 and red, or box 2 and red, that ends up being right here. My half times my 2/3 gets me the top red, and then my box 2 and then red, this is a half and a 1/4, that gets me this 1/8. I jumped straight to here, sorry I didn't cover the middle part. But now I've got to take my 2 red possibilities, add them together down here for the ultimate, oh my goodness, we're finally there, 11/24. This is definitely a place to stop the video, go back and think, take a picture of my page, but then it says tree diagrams can be used when the events are independent or dependent, and they can be also used for sequences of 3 or more events. I'm not going to explain the last parts, but I do want you to see that we do have what's called conditional probability, and a really good video of it in your list of stuff to do for this section. But I do want you to keep pointing out and noting to yourself where conditional probability is, You don't have to memorize that formula, but you got to know when to use it and how to use it, and that's why you can't just gloss through these sections. They've got to make deep sense to you. And so there's another part in this section called Conditional Probability. I would encourage you to talk through this and what it looks like and practice saying the probability of getting B given that A already happened, and what you would put in the numerator and the denominator, and then make sure that you can do the problems that I suggested in our notes. And then again, after you've done them with some notes, go cover them up, and then you go try to do it as if it was on a test, and all you had was this, your brain, and your formula card. Could you make this work? The same thing with the one at the bottom of the page of the women in the military. We're rounding out this section at the bottom of page 228 with the probabilities of at least. What I would have told you in class is to, like if you're putting this on a flashcard, that you would put on the other side that this is related to a complementary event. And it's an indirect way to find the solution, and you need to trust the process. My students in class are always kind of freaking out when we do the first one, but by the time we do the second one, they're saying that's it. And so that hopefully will happen to you as you're looking at the information in the video, and then you come over here and you are doing, like example 4-36. A single die rolled 4 times, find the probability of getting at least 1/6. You got to remember we're going indirect, and that is one of the key items to be able to do these probabilities for at least. And if you look where it falls on our chart, we looked at multiplication independent, multiplication dependent, conditional, and then the complementary events, and that's where you're going to have to remember the process when it gives you something like this, like the rolling the die in your homework, or if I give it to you on the test. This concludes all of that we are doing in Chapter 4, Section 3.